This conference will now be recorded.
Perfect. Good morning, guys. Hope you all have enjoyed the earlier session where we discussed very basic concepts of linear regression. What is linear regression? What's line of graph? What is cost function? And what is the error detection process? So we had to stop the practical continuation because that was quite long. So we'll resume from the point where we left the other day. So before we jump into today's session, let's quickly recap what we have learned. We have discussed about linear regression. We have discussed about the formula of linear regression. We have also explained what is theta of 0 or theta of 1, where which are used as a parameters, or they can also be called as coefficients and intercepts. I also explained you about the graph formula and how the graph works and how you can plot the graph using matplotlib. Okay. After that, we discussed about the cost function and how cost function helps you to get to the optimal best prediction enhancement process. Okay, so this graph which you are seeing right now is the optimal slope value. If you see on the left side, you see theta 1 is equal to 0, theta 1 equal to 0.184, theta 1 equal to 0.3, theta 1 equal to 0.374. So each color has got different theta value, and the graph is also a bit different than the earlier. So the cost function, if you see red, blue, green, orange, it has a slope that is called optimal slope value. Uh, it has to reach to such a stage where the value becomes prominently good enough so we can stop tweaking the parameters around. I'll explain you very clearly about this later stages. Today we have to complete our linear regression practicals, which we discussed, which we stopped in between. So before I do that, uh, you need to understand few things. We have set up a lab environment using the virtual env. I forgot to mention one important point. That important point is VirtualBox. You need to have a VirtualBox software installed. Only then you will be able to install the what you call the visualization software what I have done. Okay, so please make sure you have the visualization software installed. You can use, okay, let me show you that also. You can install this one, Oracle VM VirtualBox. This VirtualBox will give you an additional capability of hosting multiple operating systems on your machine. So this is the one that runs in the background when I activate virtual env space env. Okay, so you have to install this. There are two things which I have to highlight here. Basically, this VirtualBox environment performs perfectly good if you have 16 GB of RAM, because 8 GB will be dedicatedly used for this VirtualBox host itself. This is a software which can host any operating system in that. So as we are not hosting any operating system in it, we are just using isolated environment with virtual environment tool. I think your 8 GB RAM should do. If you wanted to host an operating system inside this VirtualBox, then that's a different case. So 8 GB RAM would suffice for now, as we are using only Python virtual environment space. Okay, so let me increase the font of this one. It should be good enough now. Okay, as I have told you earlier, I have created a working directory, and that working directory is cdml, and I wanted to activate my virtual environment python-m virtual env space env. Okay, it's getting the things done. Perfect. So let me open Jupyter Notebook from here. Perfect. It's getting opened. Superb. So if you see here, this untitled IPython notebook is the one which we are working other day. Let's open that one. Okay. We have all the things which we have stored earlier. Okay. So I want to run all these things again and give you an explanation where I have stopped. Okay. So go to cell, click on run all. Let's see what happens. It's running. I've explained you all this very clearly, how you prepare your data for machine learning. That is called data preparation or pre-processing. Okay, this has run. This has run. Perfect. I've got all the information what I need. Let's quickly recap. You have installed all the packages you want. I want matplotlib. I want numpys. I want panda, and I want scikit-learn.linear model because I'm using linear regression. Perfect. I have imported my base life index from BLI website, and I have done a head command to show how the rows and columns are looking like. Here I have used pandas read.csv function. Here also I'm using the same function, but this is an Excel sheet. If you see here, this one minute. This is an Excel sheet here. I don't want my Excel sheet to have data in proper format. That's the reason why I'm telling thousands must be separated with a comma, and the delimiter is a new tab. This English Latin one, and NA values should always be having NA. Perfect. For this also I have done GDP per capita head of 2. Now one important step I have ignored here is, if let's go one step back here. When I did the head, I also have to do something called checking the columns for that. Which column are we talking about? We are talking about life satisfaction, right? Life satisfaction column. Let's see how this life satisfaction column looks also, and just say I need head of 2. I just need 2 columns, that's it. Let's see how this will show you, because I want to see the columns of particularly this column. Okay, this shows perfect. Australia is having 7.3, Austria is having 6.9. If I do 5 of this one, let's see how it shows. Perfect. So this is how you have to verify the columns and decide, are you getting the results in desired format or not, before you jump into the pre-processing of data. Perfect. So after this, I make sure the inequality is having the column value as total, and I mentioned my index is country and my column is indicator because I'm using pivot. If you have heard about Power Pivot in Excel sheet, this is kind of that thing where you have to plot in various aspects of it. That's the reason you need to say what is your index going to be. Okay. And after this, you rename the column 2015 to GDP per capita because 2015 doesn't make good sense to me. That's the reason. And you have index country and your index equal to true. Perfect. And after that, I have joined the two tables using merge function. PD is pandas, pandas.merge. Left side, I want this table, and right side, I want this table. So left index, I want to enable left index, and I also want to enable right index. Perfect. After that, I verified if I have got the right rows and columns, and I've checked that. Perfect. And after that, I did a describe function to check what is the mean, what is the maximum, what is average, like that. I also did describe for this table as well, just to understand how the mean, minimum, maximum, average looking like. Okay. Now, let me go back. This is all done. This is all done. Now, I explained you what is remove indices. I also explained you what is keep indices because I wanted to use sample data and test data. For that reason, I have taken 7 rows as 7 rows I have put as missing data, and my sample data will be like full information out of 36. That is what it is. We plotted. If you see here, your missing data is only 1 second. Let me take the pen. This is 1, 2, 3, 4, 5, 6, 7. So this is your missing data. Your missing data only has 7 values. Like that. This is your sample data. This sample data will have around 36 minus 7. Okay, because we have splitted our data into two different data sets just to make sure we do a cross verification before we jump into the conclusions. We are perfect till this point. You understood everything. Now guys, we are going to implement what we wanted to look for. Basically what we wanted to look for is we wanted to understand how this sample data is working in line with the implementation part of it. So implementation is very simple. Now let me go ahead and do it. The first part I have to do is I have to import the numpy. I'll do that. Import. I'm not copy pasting it guys because I wanted to show how things works for you. Import numpy as np. This is the basic functionality. And after that I want to plot on the sample data, so I'll say plot it. And how do you want to plot it? I want to plot it as scatter plot, so I say scatter. Okay, it's not taking it. Scatter plot. And what is my x? My x is GDP per capita, right? So just say GDP per capita. Okay, and what is your y? Your y is your y is life satisfaction. Perfect. So you have given your x, you have given your y. What is your fig size? Your rows and your how your figure should look like? Your figure should look like 5,3. Okay, perfect. Now this is the basic thing we have done. Now guys, if you observe here, 1 second, what is the range of this one and what is the range of this one? Here it's ending at 50,000. Here it's ending at 7.25. This also you can define in your parameters on how you want to plot your x range and y range. That also we can do. Okay. So now instead of 50,000, I wanted to go one level up to 60,000. Instead of 7.25, I want to go one level up to 10. Let me do that also. Erase all the drawings. Go to the pointer. Now, if you see here, I want PLT dot axis. My x-axis should start from 0 to 60,000. I'm happy. And my y-axis should start from 0 to 1000, I would say, which can be a factor of 10. Okay. Now let's see how this looks. There is spelling mistake here. One second. There is fig size. Sorry, I have to put equal to here. Perfect. Super. This is fine. Now let me run this one. There is other error message. It has got no object of length. That was my fault, because this should be 0 comma 10. Okay, because as I said, it can be a numeric representation of 10. I have to tell it very clearly that I want it to be 0 comma 10. Now it will work. Because guys, sorry, that was my fault. X-axis start 0 and the range ends at 60,000. Y-axis starts at 0, range ends at 10. When I gave 1000, it says, boss, what the hell are you doing? The length of the vector is having a problem. I cannot define that length for you. Okay, so now if I run this, it will run perfectly. Why is it doing error message again? Quick minute, let me quickly check if my command is wrong. The other important problem here is you need to mention the indices as well. Okay, now it will work. It worked super. So the two syntax errors. One syntax error is it's not 0 comma 1000, it's 0 comma 10, and I forgot to mention the indices. This is called indices. This bit is called indices. Now I got the clear understanding of it. So this is how my sample data is looking like. Okay, can we also check like this with the other data we have for missing data? Let's see for missing data as well. Okay, if you see for missing data, see how it looks. Okay, makes sense to me. So you have understood how how you can plot your data with the matplotlib. Perfect. Now we have done it for sample data, and we also did it for missing data. Let's not waste any time. Let's go and start implementing the scikit-learn linear regression from sklearn. What are you going to do? You are going to import the linear model. Okay, perfect. From that one, I'm saying I'm giving a variable name called linear1 to my linear regression, and I'm asking linear model underscore 1 second dot linear regression. This is the syntax of linear regression. Okay, so you are going to apply your linear regression for this one. Now what I have to say is very simple. What is your X sample and what is your Y sample? Okay, I'm saying my X sample is equal to NP. NP means, as I have told you earlier, you use NumPy as NP, right? If you say, I'll explain that here, np.c functionality. 1 second, I'll explain you and then we can move on. np.c Python, yeah. See, what happens is this translates your slice objects into concatenation to along the second axis, explaining that if you have an array of 1, 2, 3, let me increase the font. I know this is quite okay. If you see here, you have an array 1, 2, 3, first one, and you also have an array 4, 5, 6, second one. Okay, now when I say np.c underscore, what happens is, let me take a pen. 1 comma 4 becomes 1 second, pen is not enabled yet. Okay, 1 comma 4 becomes 1, 2 comma 5 becomes one string, and 3 comma 5 becomes 3 comma 6 becomes one string. I also have to explain you various things in this one called tuples, and there is also other process where we have to explain about the intercepts and all, because this parameters will save various information in the form of arrays and arrays of tuples. I'll give one session on that. What is an array? What is a tuple? And how this arrays of tuples are stored in coefficients, and how arrays of tuples are stored in intercepts. I'll tell you that later. Now let's stick to the completion of this hands-on implementation. So ideally, The reason why I'm using numpy numpy.c is nothing but np.c. If I do np.c, it translates my slice objects to concatenation along second axis. Okay, so if you have one stack 1D, okay, that array as columns can be represented in a 2D array. Okay, that is the beauty of it. Now we are going to implement that one. Let me take the pointer. Cool. Now I'll move on here. So I'm going to use my np.c. Be careful. Try to understand how these things works here. np.c underscore. The reason why I'm saying is I want my sample data, right? Okay. In sample data, which column are you focused on? I'm focused on one column, that is GDP per capita column, right? GDP per capita column. Super. This is good. Now, this is your x-axis. What is your y-axis? I say y-axis same like np.c. Okay, I explained you what is np.c, so don't worry. Now, I'm going to take sample data. There is one mistake I've did here. Yeah, it looks perfect, don't worry. So in this one, which column are you talking about? You're talking about life satisfaction column. So go ahead and say life satisfaction column. Super. So very good. You have imported your linear regression. You gave a variable name called lin1 to the lin1 as a name, and from lin1 you said linear model dot linear regression. There you gave your example y sample. Now you need to fit your linear regression into this x comma y. What is that is nothing but linear regression has got set of functions which it can go and work on your x and y. What is your x? In sample data, GDP per capita is your x, and in sample data, life satisfaction is your y column. So for this linear regression to go and transform this data, I have to fit it. So let me go and fit it. How can I fit that? How can I fit it? My linear regression model function is stored in this variable called lin1. So I say lin1 dot fit. Where am I fitting it? I'm fitting it on my x-axis and y-axis. What is my x-axis? X sample is my x-axis. Okay. What is my y-axis? Y sample is my y-axis. Perfect. This looks good to me. Now what happens is, let's do till this point, and then I'll explain you what is coefficient and what is intercept. I don't want to confuse you here. Coefficient, intercepts are nothing but the parameters of the cost function for you to reach to the optimal level. So again, I'll go back to the slide. Observe carefully. If you see here, the negative slope will increase in the parameter value. The positive slope will result in the decrease of the parameter value. And the time when you reach this one with a very good performance indication, then you can ignore tweaking the parameters. We will deep dive into this further, but let's not break our head right now. Right now, all you need to understand is what is a coefficient, what is intercept, what is a cost function. Okay. For example, I'll say if I take theta1 is equal to 0, which is a blue line, it looks like this. Perfect. If I take theta1 equal to 0.184, it looks in green color, which is like this. Okay. If I take theta1 equal to 0.301, it looks in pink color, which is like this. So your linear regression model does this kinds of recursive stressing of testing and comes out with an optimal slope value. Okay. We'll park this optimal slope value discussion here because I want to continue this in next topic, because there we have to deal with it a lot. So here all you need to understand is what is your coefficient and what is your intercept. I'm gonna show that right now. Where is my terminal? I don't want the terminal, I want Jupyter notebook. Now let me run this one. All the syntax seems to be proper. Let me take the pointer, erase all the drawings. Okay, cool. Now run this one. Now observe carefully. Your linear regression has successfully completed. It says, boss, copy of x is taken. True. the fit intercept is taken true. Now what is intercept? A quick question. What is intercept? And what is number of jobs? It's 1. What is normalized? Normalized is taken as false. I'm going to show you something very interesting now. Spare a minute. I say print me the lin1 intercept. Okay. For that I can say dot intercept underscore. Okay. Let's see what happens. It gave me some xyz. Okay. I also wanted to see my coefficient. How can I do that? I'll say print linear. My linear regression function name is lin1, and for that one I have coefficient function. I say co edit coef. Okay. Now let's see. It gave me something. Don't worry. What is this one? Let's say of let's test it for other parameters. Let's say for x, if it gives any value true, that's perfect. I don't want that. I just want coefficient. Okay. Now let's understand what is coefficient and what is intercept. I'll take a pen here. For example, 1, 2, 3, 4. I have 4 columns. For example, if I say the coefficient of the first column is 0.2, and if I say the coefficient of second column is 0.2 as well, and if I say the coefficient of third column is 0.6, and if I say the coefficient value or the coefficient weight of the fourth column is 0.7, and this is my coefficient, I say coefficient as CO. Okay, let me draw a line here. Same way, if I get an intercept value which is equal to, for example, let's say I got intercept value is minus 19. The way how it works is, observe carefully guys. What did we discuss earlier? Let me go to the PowerPoint. I will take the pointer now. I have to explain the formula and then come back here. Okay, 1 second. Yeah, this one. What did I say here? I said y is equal to, it considers all the coefficients, multiply them. 1 second. For example, this one, h theta of x is nothing but your y, because you are expecting what you wanted to do. Do you see here theta 0 plus theta 1 into x1 plus theta 2 into x2 plus theta 3 into x3 plus theta 1 into x1? We are going to apply this logic into our function right now. So let me go back there. Okay, now this is my intercept value. This is my intercept value, and this is my coefficient value. Now what I say is my y is equal to minus 19. Okay, minus 19 into next value will be this one, 0.2 here. Okay, which is 0.2 into x1. Perfect, I got this, into x1. Completed. Now like that, plus minus 19 into what is the second coefficient value? Again it's 0.2. It comes here into 0.2 into x2. I'm very bad in drawing, bear with me, into x2. Like that. You have minus 19 here, intercept value, take that one, minus 19 into, what is the third coefficient? 0.6. Put it here, 0.6 into x3. One second, into x3 plus. What is my fourth coefficient value? 0.7. So my intercept is minus 19. So minus 19 into coefficient value 0.7. So I'd say 0.7 into x4. Okay, like this into x4. Like this, it goes on doing for xn. So what did we discuss earlier? Machine learning is nothing but from an experience E for a task T, if it can improve the performance of that experience at the rate, that is called machine learning. So this is one iteration of your experiment. This is other iteration of your experiment. This is other iteration of your experiment. This is other iteration of your experiment. So like this, it keeps on running. It keeps on running, and excuse me, it keeps on running. And for that to run, you have to understand what are the coefficients and intercepts. Very simple. Coefficients comes into picture when your model is already trained and you have to view those set coefficients. Okay, now after coefficients are done, you also need to check the intercepts, because intercept is nothing but it contains an array of values. What is array of values? You know, in your formula you said theta of 0 plus theta of 1 into x1 and theta of 2 into x2, right? Those theta of 0 or beta of 0, those theta of 0, beta of 0, nothing but the intercept values. Okay, so that's how the whole thing works. Always remember, always remember, you will have to carefully do this thing. Okay, so for the first time, if you do it, it will be your linear model standard process. One second, guys. One second. I think there is small. Let me correct what I have did. 1 minute. 1 minute. Let me correct what I have did. I'll erase all the drawings and do it again. 1 minute. 1 minute. I'll do it again. I want to explain it more clearly. Um, okay. Let's take the intercept value as 19, for example. Okay. When the intercept, this is I say, intercept value is I, and the coefficient is 0.2 first time and 0.3 second time and 0.4 third time, 0.5 fourth time. Okay, I'm sorry, I did a small mistake earlier. The reason is I have multiplied the intercept every time. You did not have to do it. You only have to multiply intercept only once. So the standard way of doing it is your intercept value 19, very good, and your coefficient 0.2, which is first coefficient. Perfect, I agree that this one will be multiplied with your x1. Okay, plus your second coefficient, which is 0.3 into x2. Okay, plus your 0.4, this bit, plus 0.4 into x3. Like that, you have 0.5 plus 0.5 into x4. I was I was wrong, and I admit that, because the coefficient value, the intercept value, you need to multiply only during the start of the function. However, you are not doing it. Your linear regression is doing it. But as an practical machine learning engineer or data scientist, you need to know the intercept and coefficient differences, how linear regression is going to use that. So with this one, you understood what is linear, what is, once again, just to clear all the confusion earlier, what I did is I multiplied this 19 into every x. You need not have to do it. Multiply intercept only once, but take the coefficients every time when you're doing with your features. What is features? X is a feature, x1 is one iteration, x2 is one iteration, x3 is one iteration, x4 is one iteration, like that. Okay, number of iterations can vary. Sometimes your x means one of the input of your column. You may have multiple columns, okay, and it picks one. Your column may have multiple values. It picks one value in the each run. You can take that is that way as well. So it's machine learning. Keep your mind open and keep your thoughts in multiple approaches. Okay. So with this one, we understood everything very clearly. Let me erase all the drawings and let me take a pointer now. Okay. Now, as I told you earlier, let's take the intercept is 0 and coefficient 0 and see how it looks like. Okay. So till here, I have only implemented linear regression. I have not implemented the intercepts and coefficients. Now I'm going to copy paste it, but now I'm going to add the intercepts. Let's see how that works. It's very simple. T0 I can say theta of 0, and T1 I can say theta of 1. Okay, I'm going to apply it on my linear 1 name, which is nothing but the linear regression. So for that one, I say intercept underscore. Okay, intercept underscore, I say I want the intercept of 0. 1 minute, guys. And also I wanted to get the coefficient as well. Okay, for that one I say lin 1 dot coefficient. Sorry, it's lin 1 dot coefficient underscore. Super. Now I want this for 0 and also 0. Now see how it looks. I want to get the value of t0 comma t1. Sorry, t0 comma t1 both. See guys, t0 can be said as theta of 0, theta of 1. You can also say beta of 0, beta of 1. It's up to you. I don't mind. Okay, let's run this one. Sorry, it's not O, it's theta O. Okay, now let's run this one. Super. So it gave me, do you see this? 5.821, 5.821, 2.151681, 2.1581 means the, if it has underscore 0 is the column for which you wanted to take the intercepts. This is fine. Now you understood how you can get the intercepts and coefficients. So you have done this for your sample data. You can also do the same thing for your missing data. Okay, before we do that, let's quickly do one more step, which is nothing but plotting it. Okay, to plot it, we discussed, let me take a pen. What did we discuss? We discussed y is equal to mx plus b, right? Where x is your features, m and b are analogous to your theta 1 or theta 0. Now, what is my theta 1 and theta 0? Nothing but t1 and t0. Okay. Let's make that part beautiful now. Erase all the drawings. Very simple. I'm going to plot it. To do that plotting, I need a clear vision. To get that vision, I'm going to implement my next step. So what is the next step? Very simple. You have to just copy paste the top one, but you need to tell it how do you want to plot that one. Okay. So I don't want to copy paste, but I will do it. I will write it. No problem. Okay. So the first thing what I have to do is sample data dot plot. What do you want to plot? I want to plot scatter. So I can say kind is equal to scatter. How do you do that? SCHETER, scatter. That's done. And next you say X. What is your X? GDP per capita. Be careful. It's GDP per capita. Perfect. And what is your Y? Your Y is nothing but your life satisfaction. So Y is equal to life satisfaction. Super. We got it. So what is your fixed size? I want my fixed size as 5,3. Fixed size is equal to, I did a mistake last time here, so let me know the mistake again. 5,3. This bit is done. Now what do you want your axis like? Your axis should look like x-axis. I want 0,6000, right? And I want my y-axis to be 0,10, for example. Okay, always remember you should put them in the indices. I did this mistake last time, so be careful. Till this point we are clear. Now what I want to say is, I want to say take this x as np dot instances, means for this instance put it like this. In the next instance you can change it. So for that I call linspace. Linspace means, the way how linspace works is, in numpys you have different ways of defining how you want your boundaries to look like. Okay, so in numpy we can explain, for example, if I say 2 and 3 numbers equal to 5, it just put that 2 3 into different columns. Okay, and if I say I want 3 to be sitting in one line and 4 to be sitting in one line, you can still do that. Okay, for that reason you say, okay, let me show that in an example that makes more sense to you actually. Where is this one? Okay, I open a new Jupyter notebook here, Python 3 interface. Very simple. I say import numpy as np. Okay, super. Now here if I say np dot linspace, okay, in linspace I say 2, I can say 2, and I can also say 3. For example, let's take this one, and I say numbers is equal to 5. Let's see what happens now for your practical understanding. Okay, for this one, if I run this now, see what happens. It says boss 1 2 3 4 5. Your 2,3 is broken into 5, and that is in an array. Okay, but when you talk this terms in two-dimensional array, in two-dimensional graph or two-dimensional plotting, it makes more visually beautiful for you to make the prediction. That is the reason why I'm going to use np.linspace. Okay, hope that is clear for everyone. Now let me jump into my part. So xp.linspace, very good. Here what do you want to add in your linspace? You want to add your x-axis 0,60,000. Did I give 60,000 here? It's not 6,000, 60,000 because our x-axis and y-axis looks like that. Okay, and then here I need to give my y-axis as 1000. Okay, now I'll say use my formula. What is my formula? plt dot plot. Okay, in the plot what I say is simply go and use my formula. What is my formula? My formula is take all your features, which is x, and then take your theta of 0 plus theta of 1, okay, into x. Okay, perfect. And mark that color in blue. Simple. When I say blue, it's blue color. Now let me see how this looks. Very simple, guys. Y equal to mx plus b. Okay, theta 0 plus theta 1 is your intercepts. Okay, that one you have multiplied with your features. Let me run this one. Invalid syntax somewhere. Okay, I need to give space here as well, and one comma is missing here. Now it works. Do you see that? Amazing. So your matplotlib has broken this one into 2D and you got the required outputs. So you don't know the countries yet, you only know the GDP per capita versus your life satisfaction. Very good, we got a very good sense of our data. Now let's go back and get the details for one country. Like that, I'll check for Cyprus first. Okay, for me to check for Cyprus, I say Cyprus I'm giving a variable name. That variable name should hold the data of what I'm looking for. Cyprus GDP per capita. That's the name of my variable. And out of that, I'm going to use GDP per capita, and I'm using a lock. I explained you very clearly. Lock is nothing but lock and ilock are the functionalities you use in Python to select the range of columns you want or isolate the range of columns you want. Like that, you'll say select the range of rows you want and range of columns you want. So now I'm using lock here. The reason why I'm using lock here is I want the information about Cyprus. Okay, 1 minute, sorry. Cyprus is one column, so I'm going to take that column. Okay, very good. So after taking this column, I also want other one, which is GDP per capita. So I say GDP per capita. Like this, I also want other column. Okay, so this is fine for me. All I need is I'm cared about GDP per capita of Cyprus country. Okay, now let me print this one and see how it looks. I say print the value of Cyprus GDP per capita. Okay, now like this, I also wanted to check life satisfaction. So I say Cyprus and I give a variable name called Cyprus life satisfaction, which I can say predicted life satisfaction. Okay, predicted life satisfaction. Predicted life satisfaction. Okay, what happens if I do this one is Cyprus predicted life satisfaction, and I'm picking my GDP per capita table. Okay, first let me do this one and then come back. First, let's see what happens with GDP per capita, and then we can make from there. Okay, you got 22,587. Super. Now let me predict how this looks. Okay, the prediction can be done with Cyprus I'm creating a variable name called Cypress predicted life satisfaction. That's my variable name, and this variable name is going to store the value of my function. Excuse me. Now this is done. So I want to predict it from the lin1. What is lin1? Go back here. Lin1 is nothing but you applied the linear regression model on one of the on your you have applied linear regression model on your data set. That is the value. Now that value dot predict. Okay, tab, just say tab. Okay, and in the predict, what you have to do, you have to give Cyprus GDP per capita. Just say Cyprus. This Cyprus GDP per capita is nothing but the value is showed here. Okay, now GDP per capita, and I am giving the coefficients, or I can give things like 0 and 0. And now if I say Cyprus GDP per capita life satisfaction, it should throw me the information 6.3. Okay, so this is the prediction it has made. This is the way how we can understand the life satisfaction. This is the way how we can initially plot, visualize, out uh, get the assumptions and get the predictions. So my machine learning model has now worked properly, and I implemented both linear regression and also line of model graph to make sure I understand and get the predictions of life does money makes people happy. Out of that, I tried to get the details for a country called Cyprus. All this, what you have done is you have done for sample data. Like this, you also need to do for your missing data. Simple, guys. Basically, you break your data set into test set and training set. I have done sample data and missing data. So this is the linear regression. I'm going to conclude this now because I don't want to spend too much time on this one. We have very clearly understood what we have done. So if you see here, 1 minute, let me go back to the slide which I'm talking about. This is the implementation. You have imported linear regression, and you have created your model, and you have fit your model to your dependent variable and independent variable, which is x and y, and then you made the predictions. And after you made the predictions, you plotted it, and you use scatter plotting, and you use a red color, and you can also use blue color as well if you want to use. This is the typical real-time implementation of linear regression. Like this, like this, for the same data set, we can implement scotatic. We can use various error detection methods and implement some other models. Okay, so linear regression model, all you need to understand is the formula, what is the coefficients, what is the intercepts, what is your features, what is your labels, and what is your dependent variable and what is your independent variable. Looking at that, you can start approaching the process of writing the model. Okay, so with this one we have completed end-to-end process of implementing linear regression on a small data set. The next session will be, we take this further and work on one other end-to-end machine learning project, because you understood few things now, and we have to implement those things practically and get our muscle grow. Our muscle is the machine learning knowledge. Okay, let's do some more recursive stress testing on other data sets, which I will do in the next session. So quickly, we have completed linear regression. We have covered each and every small bit that involves in the linear regression. I've explained you theta, I've explained you beta, theta or beta or t0 or t1, anything is interception coefficients. I explained how things works. One correction, the intercept value 19 need not to be multiplied every time. The intercept value 19 must only be multiplied in the start, but your x1 must be multiplied with theta 1, which is nothing but your coefficient. Your x2 must be multiplied with your theta 2, which is coefficient 2. Your x3 must be multiplied with your theta 3, which is coefficient 3. The reason why I'm repeating this one is people tend to confuse a lot looking at the formula. Formula has got nothing to do. Your formula is already being interpreted by Python the proper way, but when you say you are a real-time data scientist, you need to know how things works under the hood. That is all my attempts in repeating few things again and again. Hope you have enjoyed this session. Thank you so much. The next one will be the most important one, which explains your mathematical functions and linear algebra functionalities. And I'll show how we can do some 2D, 3D plotting. So you can link this class, yesterday's class, and tomorrow's class, and I'm sure you'll start loving data science. Okay. Thank you so much for your time. I sincerely appreciate it. Have a great day, everyone. Thanks.